rise method. Title: To determine the surface tension of water by the capillary rise method using a traveling microscope. Introduction. It is found that when a capillary tube open at both ends is dipped in a liquid which wets the walls of the tube, the liquid rises up in the tube. This is called capillarity. The surface tension T of the liquid can be found using the formula T is equal to HR rho G upon 2 cos theta, where H is the height to which the liquid rises, R is the radius of the capillary tube, rho is the density of the liquid, theta is the angle of contact for liquid and glass, and G is the acceleration due to gravity. Apparatus. We require following apparatus to perform this experiment: a capillary tube, a beaker containing water, a traveling microscope, a cork, a rubber tube, a wooden block, a stand, pin. Procedure. Let us get familiar with traveling microscope. This is main scale of horizontal scale, and this is vernier scale of horizontal scale. Similarly, this is main scale of vertical scale, and this is vernier scale of vertical scale. This is wide adjustment screw for horizontal, and this for vertical scale. Here, this is minute adjustment screw for horizontal, and this is for vertical scale. This is telescope. This is objective in front of which the object is placed. This is eyepiece through which the object is seen. This is telescope screw used for focusing. Let us first determine the least count of the traveling microscope. The procedure for finding the least count is same as that used for vernier calipers. The least count of the traveling microscope is given by the formula least count is equal to value of smallest division on the main scale upon number of division on the vernier scale. Please note how to read main scale. For example, each division is 0.05 centimeters. Division after 5 is 5.05. Second division is 5.1. Then 5.15. Then 5.2. Then 5.25 and so on. Therefore, division before 6 is 5.95 centimeters. The value of smallest division on the main scale is half millimeter, that is 0.05 centimeter. Now, observe the total number of divisions on the vernier scale. There are 50 divisions. So the least count is 0.05 centimeter upon 50 is equal to 0.001 centimeter. Part 1. Determination of the radius R of the bore of the capillary tube. Let us now determine the radius R of the bore of the capillary tube. Let us do some preliminary adjustments. Keep objective and capillary touching each other as shown. Slowly shift the capillary away from telescope such that the distance between objective and capillary is 6 to 7 centimeter and along the same axis. See through eyepiece and using telescope screw, focus properly. Once focused, now close the wide adjustment screw of horizontal scale and using minute adjustment screw, make vertical cross wire tangential to the bore. Now, note down the reading on horizontal scale. For noting main scale reading, concentrate on vernier scale 0, that is first division of vernier scale. Whichever division vernier scale 0 crosses on the main scale becomes main scale reading. In our case, vernier 0 is between 9.7 and 9.75. Therefore, MSR is 9.7 centimeters. For vernier scale division, locate 1 out of 50 divisions of vernier scale which coincides with any one of main scale. Here, it is 15th division of vernier scale is coinciding. Therefore, VSD, that is vernier scale division, is 15. Note the reading X1 in table 1, observation number 1. Main scale reading A 9.7 centimeter, coincident vernier scale division N 15. Vernier scale reading B is equal to N into LC, that is 15 into 0.001 centimeter is equal to 0.015 centimeter. Total reading A plus B is 9.7 plus 0.015, that is X1 is equal to 9.715 centimeter. Now again, using minute adjustment screw of horizontal scale, adjust the vertical crosswire tangential on other side of the bore. Observe main scale reading, which is 9.75 centimeter, and the coincident vernier division is 25. Note the reading X2 in table 1. A 9.75, N 25, B is equal to N into LC is equal to 25 into 0.001 is equal to 0.025 centimeter. The total reading X2 is equal to A plus B is 9.75 plus 0.025 is equal to 9.775 centimeter. The difference mod X1 minus X2 gives the diameter D1 is equal to 9.775 minus 9.715 is equal to 0.060 centimeter. Similarly, by fixing wide adjustment screw of vertical scale and using minute adjustment screw of vertical scale, make the horizontal crosswire tangential to the bore. Note the corresponding reading Y1. Main scale reading A is equal to 12.3 centimeter. N is 4. So B is equal to 4 into 0.001 is equal to 0.004 centimeter. Hence, the total reading Y1 is equal to A plus B is equal to 12.3 plus 0.004 is equal to 12.304 centimeter. With the fine adjustment screw, move the microscope tube so that the horizontal crosswire is now tangential to the bore at the diametrically opposite point. Note the corresponding microscope reading Y2. A is 12.2, N is 40, B is 0.040, and Y2 is 12.240 centimeter. The difference, mod Y2 minus Y1, gives the diameter D2 is equal to 12.304 minus 12.240 is equal to 0.064 centimeter. The mean diameter of the bore of the capillary tube is given by D is equal to D1 plus D2 upon 2 is equal to 0.060 plus 0.064 upon 2 is equal to 0.062 centimeter. So, the radius of the bore R is equal to D upon 2 is equal to 0.062 upon 2 is equal to 0.031 centimeter. Part 2. Determination of the height h of the water column in the capillary tube. Now, let us determine the height h of the water column in the capillary tube. Now, blow the capillary to remove the air bubble in the capillary. After this, press the rubber tube and dip the capillary in the water. Clamp it and then release. Due to capillary action, the water will rise in the capillary. Now adjust the tip of the pin such that it just touches water surface. Please note, since traveling microscope is compound microscope, the image will be inverted and meniscus will look like this. Now focus on the meniscus and using minute adjustment screw of vertical scale, make horizontal cross wire tangential to the meniscus. Note the reading on vertical scale as before: MSR, VSD, VSR and total reading. Main scale reading A 14.30 centimeter, coincident vernier division N is equal to 15. Vernier scale reading B is equal to N into LC is equal to 15 into 0.001 is equal to 0.015 centimeter. Hence, the total reading A is equal to A plus B is equal to 14.30 plus 0.015 is equal to 14.315 centimeter. Now, raise the beaker slightly without disturbing the capillary tube and the pin. Remove the wooden block and then lower the beaker and let it rest on the table. Lower the microscope tube so that the horizontal cross wire is now tangential to the tip of the pin. Note the corresponding microscope reading B. Observation number 2. A is equal to 9.45 centimeter. N is 11. B is equal to N into LC is equal to 11 into 0.001 is equal to 0.011 centimeter, and the total reading B is equal to A plus B is equal to 9.45 plus 0.011 is equal to 9.461 centimeter. The difference A minus B gives the height h of the water column in the capillary tube. Therefore, h is equal to A minus B is equal to 14.315 minus 9.461 is equal to 4.854 centimeter. Calculations. Let us do the calculations. The surface tension of water is given by T is equal to HR rho G upon 2 cos theta. We have measured radius of the bore R and the height of the water column in the capillary H. Other quantities are: density of water rho is equal to 1 gram per centimeter cube. Acceleration due to gravity G is equal to 980 centimeter per second square. Angle of contact for water and glass is equal to theta is 0 degree. Substituting the values of R and H found from the experiment and the known values rho, G and theta in the formula, we get T is equal to 4.854 into 0.031 into 1 into 980 upon 2 cos theta is equal to 73.749 per centimeter. Result: surface tension of water T is equal to 73.749 per centimeter. Precautions: 1. The capillary tube should be along the axis of the microscope tube while measuring the diameter of the bore of the capillary tube. 2. The capillary tube should be exactly vertical while measuring the height of the water column in the capillary tube.